Namaste. Welcome to all Group 1 aspirants. Within few months and few days, you are going to write your Group 1 services examination. TSAT prestigiously, proudly giving the guidance classes to all the aspirants. So, science and technology is one of the part of out of 13 areas for the prelims examination. You know that science and technology is one of it. In that, you learn so many space technology, 5G technology, and now we are going to learn about nanotechnology. Nanotechnology is a incredible innovation by our scientists, and it has a wide application. It has a wide application in all the areas, in research, in medicine, in other branches of science, even in industries also. So, for example, so if you want to previously the chemotherapy is not giving good results, but after introducing nanotechnology, the chemotherapy is getting a good result. The reason is, so here by using the nanotechnology, we are identify the affected cell in a probe, exactly the affected cell, and we are giving a proper medicine to that affected cell, and there is a possibility of reducing that disease. So that's an application. Now we are going to discuss about what is nanotechnology, what is the history about the nanotechnology, how it is developed, and what are its application. All these things we are going to learn now. Okay. So nano, the word nano is derived from the Greek word bios. It means dwarf. It is a prefix, literally refers to 1 billionth of physical size, as you know it. So, for example, if you take 1 millimeter size particle, an object, so means we have taken 1 billionth of that size. Means you can imagine it's easy how can identify with a maximum magnifying. According to the definition of the National Nanotechnology Initiative, the direct manipulation of the materials at the nano scale. So means here, so that 10 is called deci, 10 square is called meter, deca, 10 cube is called kilo. Clear? In the same sense, 10 power minus 3 is called milli, means 1000th part. 10 power minus 6 is called micro. 10 power minus 9 is called nano. So, are you understand the definition of nano? Nano means here, so when you consider 1 meter length width object, means here you are going to take it as 10 power minus 9, means 1 billionth of that part will be magnified. So, the science of small thing, the study of science of the small things, we call it as simply as nanotechnology. The central idea of the nanotechnology is to employ individual atoms, molecules to construct the functional structures. Okay, so previously, according to the Sir Isaac Newton, okay, and Dalton, as you know that Dalton, the smallest particle in any substance is an atom. Okay, so after so much research, so inside the atom we have so many particles. We call it as nucleons. We call it as nucleons. That is called electron, proton, neutron, neutrino, positron. Like so many nucleons are there. Clear? And their size is very small. So if you want to know the position or the velocity of those particles, so some special technology is required. For example, in blast furniture of a steel plant, there is a small crack is there. So from a general eye, normal eye, we are unable to identify. But by using this nanotechnology, so that was magnified up to 10 to the power of 9 times. So we can see the image exactly where the crack was happened, and we can survive the machine also. So such a important application about this nanotechnology. So nanotechnology means It's a science of the small. It's a very, very important. Okay. So there are 25,400 million nanometers in an inch. 25,400,000 nanometers an inch. Now imagine, so 1 inch, what is the length of 1 inch? Correct? So we can divide that nano inch into 25,000 millions 4,000. 25 millions 4,000 400 sorry 400 thousands of nanometers as in 1 inch. A sheet of newspaper is about 100,000 nanometer thick, means nearly 1 lakh nanometers thick. Just a sheet of newspaper. One compared to scale, if marble were in a nanometer, then 1 meter would be the size of the earth. So if you take a small marble, and if you take it as a comparative scale, by using this nanometer, it will be 1 meter. 1 meter would be the size of the earth. The size, because we know that the radius of earth is around 6,400 kilometers. Now you can imagine, so how much it was magnified. So in such a manner, by using this nanotechnology, you can. Now I'm showing the images by using a nanometer here. 1 nanometer is 10 power minus 9 meters, means it is 0.801 meter, means 1 billionth of the meter. A human red blood cells, we have red blood cells and white blood cells, as you know it. And the human red blood cell already is showing in the second picture. Now we see the second picture. This is the second picture. So the blood cell is about 7,000 nanometer wide. This is a 7,000 nanometer wide. So in this manner, you can identify the nano scale. Now see, these are the 4 pairs of molecules are less than 1 nanometer wide. Just 1 nanometer wide means 4 pairs of molecules. These are 1 pair of molecule. 4 pairs of molecules is less than 1 nanometer wide. Now see, 1 nanometer is a tennis ball. If you take it as a 1 nanometer tennis ball, a tennis ball is to be similar size of the earth. And your fingernail grow about 1 nanometer per second. See how interesting it is. For everyone, human being fingernail will grow about 1 nanometer per second. And human hair, see this hair, our hair is nearly 50,000 to 100,000 nanometer thick. So now you can see, because generally by using our hair fall and the reason for hair fall, and there is a break in the hair, all these things can be seen properly by applying this nanotechnology. So like we have wide application in all the branches of science, not only branches of science, medicine, industry, and all these things we are going to discuss about. Is it clear? So now we will see some more things here. What is the history of the nano? The first ever concept was presented in 1959 by the famous professor of physics, Dr. Richard Feynman. He identified, he introduced, or he discovered the concept of nanotechnology. So this is a very important bit for you, for who introduced, who discovered the concept of nanotechnology. First is the famous professor of physics, Dr. Richard P. Feynman. In 1959, he was invented. The invention of the scanning tunneling microscope in 1981 and the discovery of fluorescence in 1985 led to the emergence of nanotechnology. The supporting discoveries or innovations are the invention of scanning tunneling microscope in 1981. This is the first one, and the discovery of fluorescence in 1985 leads the emergence of the nanotechnology. The term nanotechnology has been termed by Norio Taniguchi in 1974. So see, these three are three important objectives for you for the preparation. One is who invented the nanotechnology, means here Dr. Richard P. Feynman is invented. So who named this technology as nanotechnology? Who termed this technology as nanotechnology is Norio Taniguchi in 1974. And what is the concepts or innovations which helps or which leads for the emergence of nanotechnology is scanning tunneling microscope and discovery of fullerenes will be another technologies which supports for the emergence of nanotechnology. So now we are seeing the image of the Richard Feynman, the father of nanotechnology. So generally, one more question may be asked to you in the examination. Who is the father of nanotechnology? Physics Richard Feynman, the father of nanotechnology. 1 nanometer is 1 billionth of meter. That is 10 power minus 9 of a meter. This is also a very, very important. 10 power minus 9 of a meter is said to be a nanometer, or 1 billionth of the meter will be said to be as a nanometer. And the Richard Feynman is the father of nanotechnology. And Professor Norio Taniguchi coined the term nanotechnology. These three are one more important objectives for you for the preparation of this nanotechnology concept. Now we are seeing the image of the nanotechnology for the atom. So atomic technology here I'm going to discuss about how it is useful in the various branches of science. Nanotechnology is the manipulation of matter on a near atomic scale to produce new structure. So generally the 10 power minus 8 meters are called angstrom units. That is generally the radius of the atom will be measured in angstrom units. That is 10 power minus 8 centimeters or 10 to the power of minus 10 meters. Okay, and 10 power minus 13 centimeters will be considered as Fermi. Curie, that word. So here to produce new structures, materials and devices, generally that nanotechnology is using. The nanotechnology promises a scientific advancement in many sectors such as medicine, consumer products, energy, materials and manufacturing. So this is a very, very important. In the scientific research and scientific development and scientific advancement, this nanotechnology has a wide applications and it penetrates in all the branches of sciences to invent, to discover new structures, new materials, new devices. So generally nanotechnology are using. Okay, so now I am showing one image of that one. Actually, the fascination with the nanotechnology stems from these unique quantum surface phenomena that matter. So this is a quantum and surface phenomena of the matter. You are seeing the image. It exhibits at the nanoscale. They improve existing industrial process, materials and applications in many fields in and entirely new ones. So it is completely new materials, new things will be going to be discovered by using this nanotechnology. Clear? Okay. So many benefits of nanotechnology depends on the fact that it is possible to tailor the structure of materials at extremely small scales to achieve specific properties, thus greatly extending the material science toolkit. Using nanotechnology, materials can effectively be made stronger, lighter, more durable, more reactive, more sieve-like, better electrical conductors, among many other traits. Many everyday commercial products are currently on the market and in daily use that really on nanoscale materials and process. We are using this nanotechnology with more stronger, more lighter, more durable, or more reactive for the existing those things here. That's the reason. So now this, by using this nanotechnology, this supercomputers also is doing robo operations. Now we are seeing the robo operations done with the this nanotechnology. Clear? And now we are getting medicine, nano medicine also. We are getting the nano medicine also. So you have suffering with different chronic diseases. So chronic, if you give one medicine to a patient, so there is some side effects, correct? Because it may reach at any organ of our body. But by using the nanotechnology, so the medicine is given to the affected or diseased organ directly or exactly place. The operations also done by exactly this nanotechnology, and new organs also are developed by using this nanotechnology. That's a very, very important thing. Nanoscales additives or surfaces treatments fabrics can provide lightweight ballistic energy deflections on personal body armor, can help them resist wrinkling, staining, and bacterial growth. Clear nanoscale films on eyeglasses, computers, and camera displays, windows, and other surfaces can make them water and residue repellent. So, entire effective, self-cleaning, resistant, and ultraviolet or infrared light, anti-fog, antimicrobial, scratch resistance, are electrically conductive. See, so now these are the wide applications. So if you want to see anti-reflective, self-cleaning, resistance-based, ultraviolet or infrared light, anti-fog, antimicrobial, and scratch resistance are electrical conductive. So all these will be done by using this nanotechnology. Is it clear? So that's a very, very important. And now we are developing nanoscale films on eyeglasses. It's based on computer and camera displays, the windows and other surfaces. So one image will be magnified and it's shown with more effective, more beautiful, and so the parts, inner parts also will be clearly displays. And the windows and other surfaces can make them water and residue repellent. So all these things are very, very important. So if you want to make a treatment, a surface treatment, especially for the fabrics, so if you want to give a beautiful design for a fabric, so by using this nanotechnology, we can do the different kinds of the surfaces, and we can give lightweight ballistic energy deflections also. This is a very, very important. Okay, a lightweighting of cars, trucks, aeroplanes, boats, spacecraft could lead to significant fuel savings. This is a very, very important. Lightweighting of cars. So now recently we are getting lightweight cars, trucks also. Now observe it, the development of these automobile industry. So we are getting more advanced, more sophisticated, more enhanced cars and driving facilities also, correct? So because of by applying this nano technology, and even for aeroplanes also, even for boats and spacecrafts also could be lead to a significant fuel saving by using this nanotechnology. So we are saving the fuel also. Nanoscaled additives in polymers, especially in polymer technology, polymers composite materials are being used in baseball bats, tennis rackets, bicycles, motorcycles, helmets, automobile parts, luggage, and power tool housings, making them lightweight, stiff, durable, and resilient. So see how we can apply nanotechnology. Now we are shifting the total era, a scientific era, into from general to nanotechnology. Everything, operations, even now, just now I said, so baseball bats, tennis bats, rackets, tennis rackets, bicycles, motorcycles, helmets, automobile parts, luggages, power tools, tool houses, making them lightweight, stiff, durable, and resilient. So, we can prepare, we can manufacture all these things by using nanotechnology and nanoscale editors, especially in the polymers. It composite materials. So we can prepare a composite materials from the nano. And the very important of this nanotechnology is application in bioengineering. Nano bioengineering of enzymes is aiming to enable conversion of cellulose from wood chips, corn stalks, unfertilized personal grasses, etc. Ethanol for fuel. Now we are using the ethanol as a fuel, as you know it. And cellulosic nanomaterials have demonstrated potential applications on wide array of industrial sectors, including electronics, construction packaging, food, energy, healthcare, and automotive and defense sector. So this is also for food preservatives, for automobile engineering, for healthcare products, and for the construction also in the electronics field for different kinds of things here, 3D printers, okay, and even for the 5G technology and industrial sectors, even for potential applications, cellulosic nanomaterials have been demonstrated for potential applications. This is a very important question to you. So the cellulose nanomaterials have been demonstrated in the potential applications, and unfertilized perennial grasses, corn stalks, wood chips, cellulose from conversion of cellulose from wood chips. All these things done in the bioengineering. So the bioengineering especially targeted the enzymes. Clear? Okay. And one more, now we are using ceramics, correct? Non-structured ceramic coating exhibit much greater toughness than conventional wear resistant coatings for machine parts. So now we are getting the ceramics for our different purposes. So now we are using bathroom commodes and other things. Ceramics are you are using even for glossaries also, correct? For all these things we are using a ceramics, and the ceramic coating also exhibited much greater toughing than conventional wear resistant coatings. And machine parts, nanotechnology enabled lubricants and engine oils also significantly reduce wear and tear, which can significantly extend the lifetime of moving parts and everything from power tools to industrial machinery. So this by applying this nanotechnology, we can increase the lifespan of the power tools, and we can use it in all industrial machinery also. It significantly reduce wear and tear. And one more, and the nanotechnology can be used in the especially in the lubricants and engine oils also. So lubricants and engine oils significantly reduces wear, means now the usage of these lubricants will be minimized, and the conventional wear resistant coatings also are minimized. Now the ceramic coatings also by using nanostructure. Now this is a very important. As you know that our computers we have RAM and ROM, correct? So in our computers we have RAM and ROM. Now by using nanotechnology we are using MRAM. MRAM means here magnetic random access memory. MRAM, using magnetic random access memory, the computers will be able to boot almost instantly. So for booting the computer it takes more time, but now after applying this nanotechnology, so we have magnetic random access memory, MRAMs. When you use the MRAMs, computer will be able to boot almost instantly, immediately in fraction of seconds it will boot once again. The MRAM is enabled by nanometer scale magnetic tunnel junctions and can quickly and effectively save data during a system shutdown or enable resume play features, correct? So for example, you want to suddenly your system was shut down, so you want to enable the resume the play features. and you want to save the data effectively and quickly, this nanometer scale magnetic tunnel junctions will play very important. So this is a very important application in the nanotechnology. The MRAM. So this MRAM means a magnetic random access memory. So generally we are using RAM, RAM, that is a read-only memory, and read random access memory. These are the two kinds of memories. Everyone you know that. So now by using nanotechnology, we are using magnetic random access memory, that is MRAM, which is able to boot almost instantly. So you have to remember this one in point of your examination. Clear? And a commercial application have been adopted for gold nanoparticles as probes for the detection of targeted sequence of nucleic acids, and gold nanoparticles are also being clinically investigated as a potential treatment for cancer and other diseases. This is a very important application of nanotechnology, that is nanoparticles of probes for the detection of, already I said, so they can detect the affected the organ or the cell by the cancer, and the target sequence nucleic acids and gold nanoparticles are also being clinically investigated and potential treatments for the cancer and other diseases. In the chemotherapy, so it identify the exact position of the affected cell, and the medicine will be given that particular area, or the part is going to be removed from the affected area exactly like this nanotechnology will be used. Okay, the nanotechnology is being studied for both diagnosis and treatment of atherosclerosis, or the buildup of plaque in arteries. Okay, in one technique, researchers created a nanoparticle that mimics the body is good cholesterol known as HDL. If you have a good cholesterol in our body, that is called HDL, high density lipoprotein, which help shrink plaque. This is a very important. So one researchers generally by using this technology, nanoparticles, the name of the nanoparticles is mimics. Mimics is the nanoparticle which is the good cholesterol known as HDL. HDL means high density lipoprotein. Clear? Okay. And the nanomedicine researchers are looking at ways that nanotechnologies can improve vaccines, including vaccine delivery without the use of needless. Researchers also are working a creative universal vaccine scaffold for the annual flu vaccines that would cover more strains and require fewer resources to develop each year. As you know that, so now we are suffering with fevers and other flu affected things. So then government is, of course, researchers, medical researchers are using this nanomedicine. They are going to give a flu vaccine that is called, simply it is needless. It's needless, no need of giving any need for giving a vaccine to it. That's a good application. The nanotechnology is also being applied to oil and gas extraction through, for example, the use of nanotechnology enabled gas lift valves in offshore operations, or the use of nanoparticles to detect microscopic downwell oil pipeline fractures. Clear? So, and in the gas line, gas pipes, so if any kind of fractures happens, so by using this nanotechnology, we can clearly identify. Now we are seeing a film that is called a nanotechnology can be incorporated into solar panels. It's a solar panel to convert sunlight to electricity more efficiently, promising inexpensive solar power in the future. Nanostructured solar cells should be cheaper, manufactured, and easier to install, since they can use to print like manufacturing process and can be made in flexible rolls rather than discrete panels. Now previously we are using a very big solar panels. Now after introducing this nanotechnology, no need what you are seeing that this simply is called a solar panel. This will be now simply film. This kind of film will extract the solar energy and convert it into the sunlight will be electricity. This is a very good application. Clear? So nanotechnology could be meet the need for affordable, clean drinking water through a rapid, low-cost detection and treatment of impurities in water. So nanotechnology could help meet the needs for affordable, clean drinking water through rapid, low-cost detection and treatment of impurities in water. Now we are using so many water purifiers, you know. So now after using this nanotechnology, which is a very cheaper and it gives a low-cost detection for treatment impurities in the water, and which is a totally highly hygienic. And the engineers have developed a thin film membrane with nanopores for energy efficient desalination. So this molybdenum disulfide, this is a very important molybdenum disulfide MOS2 membrane filtered 2 to 5 times more water than current conventional filters. By using this nano technology, by using these molybdenum disulfide membranes, so it filters the water 2 to 5 times more better than the current conventional filters. These are the some more applications of the nanotechnology. Clear? So prepare all these things and prepare for the examination. Thank you.